Hello everybody, it's the Soundmachines NS1 Nanosynth. This is not new, I've had it for a while, actually had it before I got any of this, but once I started building the Euro rack system, I stopped using the Nanosynth and it's been packed up in a box for a while, actually more than a year. The reason it is out right now is because after discovering that the camera wouldn't run on the USB power coming out of this case, I wanted to check my other outboard devices to see if they would, and this one is currently running on power coming out of there, out of that case. The Nanosynth is a fully self-contained, full-voice analog synthesizer. This is a great introduction to analog synthesis because it contains like the functionality of 12 modules, and it's only the price of maybe one medium priced Eurorack module. And it's very compact. You can see compared to my hand, it's pretty small, and it's got oscillator. You've got two variable voltage sources controlled with a pot. You've got two LFOs, two attenuators, ADSR envelope, a filter with low pass and band pass, a VCA, three little buttons that output a gate when you press them. There's a sub utility. There's two unity gain mixers, a 1/3 mixer, a sample and hold, a ribbon touch controller. Over here you've got logic operations. You have a clock divider, a voltage divider, and sockets to connect external sensors like pots and those photo resistors, light sensitive things. You can plug them in here, and then down here is the Arduino section. It has a Leonardo chip inside, and if you get into Arduino coding, you can make the chip do all kinds of tricks, and these are the breakout points for the chip pins. There's no internal patch. You have to patch it up, wire it up, make connections to make anything happen. It's these tiny little breadboard style connectors. The one disadvantage is that once you start patching it up, it gets real crowded, and it's hard to get your fingers in there with these tiny little pins, and you have to tilt it and squint down at the panel to make sure that you are sticking the pin in the correct hole. It runs on 0 to 5 volts. It's a unipolar system. Now it can communicate with Eurorack with the use of the Nano Bridge, sold separately, 14 jacks corresponding to 14 holes on this tiny breadboard, and then there's an array of resistors and diodes to protect the Nanosynth from overvoltage, because the manual says voltages outside of its range can damage the Nanosynth. And that light, I don't understand. There are two rows on this strip. One says protected, one says unprotected. Why build this and then have unprotected connections on it? I don't get it. But as long as you're careful and pay attention to what you're doing, you should be fine. The other thing you have to know, which wasn't explained anywhere, I had to figure this out on my own, maybe I should have known. The Nano Bridge has to be powered and grounded from the Nanosynth. I was plugging things in and connecting them over here and nothing was happening. Well, that's because 5 volts and 0 volts have to be connected. There are lots of places on the panel to do it. Since I don't use the Arduino, I'm going to do it over here. This is 5 volts. Connect it to a 5 volt. And then I need 0 volts. Connect it to 0 volts over here. Now the Nano Bridge is connected, powered up, ready to go, and I'm going to cut here and make a patch, which will take me a while, but for you, no time at all will have transpired. Oh boy, this is complicated. So let me see if I can walk you through it quickly. I have a random voltage being clocked by a gate from Dresno. The random voltage is controlling the cutoff frequency of this filter along with one of the LFOs. I'm combining them to affect the cutoff frequency of the filter. The pitch of the oscillator is being controlled by tonic, receiving 2 gates from Dresno for a very simple pitch sequence. From here, the oscillator has several different waveforms. I'm using square with pulse width modulation controlled by the other LFO, the sub, and the sol, and those are going into the 1/3 mix. However, I'm using 2 gates from Dresno going through the NOT logic operator here to invert them because of the way the sum sub utility works, using the sum sub as 2 VCAs to gate those waveforms into the 1/3 mix. Now that mix is going into the filter. Low pass from the filter goes to the VCA. VCA is controlled by the envelope, and the envelope is being triggered by a Euclidean pattern from Little Nerd and this chance trigger down here. Both of those are going into the CMOS party logic module, and I'm using the OR output to combine them so this fires every time either or both of them strike. And that just gives me the Euclidean with a little bit of an extra random hit, so it's not just the same thing repeating over and over. And this is what it sounds like. Let me add a little reverb. Oh yeah. Now I added some rhythm to this. Grids is controlling T-kick and hat. Hat is getting some DKCV from one of these Dresno gates, attenuated. And for channel 2, the snare drum channel, I am using digital noise from Noise Square going through the top half of the LXD. And here's my drum set. I like that quite a bit, and I think I will, there's a temptation to slap more layers on, but I probably ought to just keep that, and I'll record it and then see what else I can do with it. It needs a melody or something to turn it from just a mindless groove into a song. I want to try to make a song. But I do like that beat. I think it turned out nice. Anyway, thanks y'all for watching. Check out my Patreon and my Bandcamp if you got the time. And like and subscribe if you enjoyed this, and I'll catch you next time.